All right, we are moving on to 2.7. We actually don't do 2.6, and we're going to talk about absolute value and what they look like. We're going to talk about the graphs of absolute value functions. So here's a picture, just a screenshot from the calculator. When you draw an absolute value function, you're going to notice it looks like a V. You'll hear me say that a lot, and we'll talk about V graphs. Essentially, an absolute value has two branches. It has the branch that has this positive slope, and it has this branch that has this negative slope. And then right in the middle, we call that the vertex. So that point of the V is referred to as the vertex point. So you could actually think of a absolute value graph as like a piecewise, meaning it has different pieces. So this top piece is the positive part, the bottom piece has the negative slope, and then this is my vertex here. So I want to play around a little bit on your calculator so you can see what these graphs look like. So I'm going to pull up my calculator. I'm going to tell you a couple buttons that I'm going to hit. On your calculator, if you go to y equals is the upper, very, very upper left button on your calculator. And right now on your calculator, you should see the words plots. Nothing should be highlighted. There should be nothing written. You want a totally blank calculator. If you were to graph just the absolute value of x, you're going to hit the math button. You're going to go over to number, and then you're going to hit absolute value, and you're going to type in just x. X is the button that's next to the alpha. It actually has an X first. You're going to hit at X button. If you hit graph, I'm just going to right now hit zoom. Zoom is in the middle of the top row, and 6. That's going to get us what's called a standard window, a 10 by 10 window. So here's the graph of the absolute value of x. If I want to change it, if I go back to y equals, I'm going to make it the absolute value of x, and then I'm going to put a +2 after the absolute value. And I'm going to notice what it does to the V graph. So if you hit the graph button, which is the upper right button, you'll notice that that V graph, it still looks like a V, but it's been shifted, and it's been shifted up 2 spaces. If you go back to y equals and you change that +2 to a -4 and hit graph, what you're going to notice is it's still the same V graph, but it got shifted, it got slid downward 4 spaces. So you can see what happens here with this is doing what's called a vertical shift. It's moving it up and down. Shift. Now, let me go back to that calculator. Go back to y equals. I'm going to start over. I'm going to go to math, over to absolute value, and I'm going to type in x + 3, and I'm going to do all of it inside the absolute value bars, and I'm going to hit graph. Now you'll notice that same V that we started out with originally has been moved to the left 3 places. So what has happened is that vertex has shifted over 3 places. If I go back to y equals, and I change what's inside and make it a -7 and hit graph, you can probably guess what's going to happen. It took that graph and it shifted it to the right 7 spaces. So what's happening here is you have a horizontal shift, meaning it's moved to the right or to the left. So if we look at a graph of an absolute value, what you'll notice is the part inside the absolute value is going to be what shifts it right or left. And what's outside of the absolute value is going to be what shifts it up and down. I'm going to summarize all of this in another slide, so don't worry about writing this down now. I'll tell you exactly where you need to write down. Now let's talk about what else is going on around the absolute value. So let's go back to the calculator. I'm going to go back to y equals, and I'm just going to clear this out. And I want to show you what happens if you put a negative sign, so your negative is your very bottom button, in front of your absolute value. So let me show you what this looks like. What it does is it takes that same V graph and it flips it. We would say it reflects it, or it flips it over the axis. So when you have that negative, it's going to flip or reflect that axis. Finally, the last thing we can do with this absolute value graph, show you one more change, go back to y equals, get rid of that. If I put a 2 in front of my absolute value, so I put a 2, go over to absolute value of x, here's what this does. It takes that V, and what it does is it makes it narrow. It actually stretches it out. We say that this is a stretch. It makes it narrow. Versus if I put a number in front of the absolute value that is a fraction. So let's try 1/3. Math, absolute value of x. What that does, we call this a compression, or it makes this wider. So it compresses or makes the graph wider. The reason it does this is it changes the slope of the branches. So when I have a slope that's bigger than 1, it makes it steeper, and it looks like it takes the graph and just stretches it out and makes it very narrow. Versus if I make a graph a slope less than 1, it has a very gradual slope, and that compresses it and makes it wider. So here's the slide that you want to make sure you're comfortable with all this. These are all the key information here. So your A value is going to tell you if this opens up or down. So if I have a positive A value, we're going to say that it opens up. It's going to look like this. If I have an A value that's negative, we're going to say that it opens down, meaning it looks like this. So it reflects it or flips it. We're going to have this piece in here determine if it goes to the right or to the left. If it's x minus h, it's going to go to the right that many spaces. If it's x plus h, it's going to go to the left. So it's going to move that V graph right or left. It's going to be a horizontal switch. Your K value, let me come down here. If I have a positive number at the end, so like a +5 or a +2, this is going to make it shift up. If it's a minus K value, it's going to make it shift down. So every single graph, we can talk about how it shifts. Does it go right? Does it go left? Does it go up? Does it go down? Does it flip? Finally, that A piece is going to represent slope, and that's what this last part here is explaining. If your A value, and you can ignore the negative because the negative is talking about just if it flips, if my A value is smaller than 1, so like 1/2 or 1/3, that's going to make it a wider graph. We're going to say that it compresses the graph. If your A value is bigger than 1, like a 2 or a 3, that's going to make it narrower, and we say that it stretches the graph. The A value will always represent the slope of each ray or of each branch. So this is an important part that you want to make sure you put something in your notes to describe the shifting. Now your homework today is going to be a little different. Rather than doing a Delta Math, I'm going to have you do a quizzes, because I think these questions are better done in a very quick kind of multiple choice environment. So you're going to be given pictures that you're going to have to match. You're going to be given graphs where you have to describe the shift or talk about the formula. Finally, the last piece that I didn't mention here, your symmetry. Every graph that is an absolute value graph, we can say it has a axis of symmetry. It is going to be a line that splits it equally, and it's going to be a line that goes right through the vertex. I'm going to explain it better in the next slide. So here's what we're going to do here. We're going to look at these equations, and we're going to talk about the shift. We're going to talk about, does it go up or down? Does it go right or left? Does it flip upside down? And then we're going to use that to draw a picture, talk about where the vertex is, where this axis, that symmetry line is. So with this first one, what we notice is that it has a -2 afterwards. If it has a -2, what that means is it goes down 2 places. Which means on my graph, instead of starting at the origin, which is where you want to think of like your basic function or your parent function starting, you're going to go down 2 places, and you're going to put a point down 2 places. So let me draw it a little differently. Let me draw it like this so you can actually see it. We're going to put a point right here. There we go. Now, when I draw my branches, so my normal branch is going to have a slope of 1, meaning we're going to go up 1, right 1, and we're going to go up 1, left 1. So we're going to have these 2 points, one going up and to the right, one going up and to the left. That's how we're going to draw this V graph. So what you basically have is you have the same V graph as your basic absolute value of x, but it just got shifted down 2 spaces. So my vertex, I'm just going to use a capital V for vertex, is at 0, -2. Your axis of symmetry, so when we talk about axis of symmetry, will always be a vertical line. So the way we write vertical lines is x equals, and it will be the x value of your vertex. What that means is if I were to draw a line at x equals 0, I'm just going to draw a dotted line, it splits this V graph into 2 equal pieces. Kind of like how the body has a natural symmetry line when you just kind of divide it right down the middle. Same idea here. This graph has a natural symmetry line. The next one, from this, we know that it goes left 2 spaces because of the +2 in the absolute value. This tells me I'm going to go up 3 spaces. This is going to make it flip upside down. So from my graph, I'm going to go left 2 and up 3 from the origin and put a point there. That is my vertex point. Then when I draw it, instead of going up and over, I'm going to go down and over. So it's going to go down 1 over 1, down 1 over 1, and that's what's going to create this V shape. Notice it is upside down, or it flips. So that means my vertex happens at the point -2, 3. -2 because it goes to the left 2, up +3 because it goes up 3. And my axis of symmetry is going to go through the point x equals -2, meaning that it splits it right down the middle with a vertical line there. So again, every piece of the equation matches up to what happens to the graph. What is the transformation or the shifting? Same idea here, and this one has a couple new things to it that I want to talk about. So this one is going to tell me that it's going to go to the right 3. Anytime you have a minus inside the absolute value, it's going to go right. This is telling me it's going up 4. Now your number in front of here is a 1/3. That's going to represent the slope. And what that's going to do, and I'll show you on the picture, is it's actually going to make a very wide V because that slope is less than 1. So on your graph, you're going to go right 3, up 4, and you're going to put a point. That's your vertex point. So right there. When I draw it, because my slope is 1/3, I'm going to go up 3 and I'm going to go, I'm going to go up 1 and right 3. So I'm going to go up 1, 2, 3, I keep saying it backwards, up 1 space, and then I'm going to go to the right 3 spaces and put a point. And then I'm going to go up 1 and I'm going to go to the left 3 spaces to get the other side of the V because I want it to be symmetric. And notice how very wide this graph is. That's what that 1/3 does. It kind of opens it up. We talk about it like compressing, like somebody who's pushing down on it and kind of stretch those branches further out to the side. So what this tells me is my vertex is at the point 3, 4, because it went right 3 up 4. And my axis of symmetry is x equals 3, because that is a line that splits it right into 2 pieces. Now for the one next to it, this is going to tell me that it goes right 1. This is going to tell me that it goes down 3. And this number is my slope. And since that slope is bigger than 1, it's actually going to become a very narrow graph. And if you're not sure about that, you can take a look at the picture when you put it together. So I'm going to go right 1, down 3, and put my vertex point. And then when I draw my branches, I'm going to go up 2, right 1, and then I'm going to go up 2, left 1 to get that symmetry of the 2 branches. And notice how that V graph is much more narrow. We would say that it's been stretched. You've like pulled the branches up and it has a narrow graph. So that means my vertex is at the point 1, -3, and my axis is x equals 1. Now, one thing I want to mention with domain and range, and I'm not going to get really, really specific in this, but you should notice with the domain, your domain is going to be everything. Your domain is going from -infinity to all the way to +infinity, or in other words, you can say all real numbers. Your range is going to be limited because your heights, like for example, the one right above here, this one right here, the lowest this graph ever gets is a height of 4. So this graph would have a range of 4, but then it just keeps getting higher and higher and higher. I'm not going to ask a bunch of things about domain and range, but I did want to mention that you can write it as an interval. Your domain will always be everything, all real numbers, all the way to the left, because it extends in both directions, left and right forever, but your range is limited. So here's one, same thing. We're not going to graph this, but we're going to do the same thing with listing things. So this one goes, because of this x plus 1, it's going to go left 1 space. Because of this plus 4, it's going to go up 4. And this is going to flip it upside down. It's also going to make it narrow because it has a slope of 2. So for this, we're going to write down our vertex is at -1, 4, because it goes to the left 1 and up 4. My axis would be at x equals -1. And really, that's everything I need to know. I went left, I went up, I flipped. That's all I need to know on this one. For my next one, because of what's in the absolute value bars, this is going to go to the right 3. Because of what's at the end, this is going to go down 5. And all this does is it's going to make it a little wider. It's not going to flip because it's not negative, but it has a slope that is less than 1. So my vertex is 3, -5, because it goes to the right 3 and down 5. And my axis is x equals 3. That would split them into equal pieces. Now, the last thing you're going to be asked to do with these is kind of go in reverse. I give you a graph, and then you tell me about the equation. So you want to write down, what do you notice? What shifting do you notice happens? It makes this much easier. So here's my vertex, and it looks to be at the point 1, 4, because it goes right 1 and up 4. So what that tells me is in my absolute value, it must be an x minus 1 and a plus 4 afterwards, because it's going right 1 up 4. Now I know that the number in front of the absolute value has to be negative because it's flipped upside down. The other thing I can figure out is the slope. So with this, it goes down 2 and then it goes right 1, which means my slope is a 2 over 1, or just a 2. So that's my equation for this. So that's going to just equal y, or equal f of x. Again, it flips, that's why it's negative. It goes right, that's why it's a minus 1. And it goes up, that's why it's a plus 4 at the end. This one over here is going to a vertex. It's going left 2, down 3. So my vertex is negative 2, negative 3. So that means my equation, since it goes left, is going to be x plus 2. And since it goes down, it's going to be minus 3. And then the slope, it's going up 1. It's going right 3. So if I go up 1, right 3, it has a slope of positive 1 over 3. And it is positive because it opens up. So that's what you should be comfortable doing with absolute value graphs. You should be able to recognize the shift or the transformation. Does it go up or down, right or left? You should be able to identify if it flips upside down or reflects over the axis. The word flip and reflect can be used interchangeably. And you should be able to recognize the slope of each of the branches or each of the rays to help you figure out that leading number, that leading coefficient. So that right there is everything you need to know about absolute values.